Assalamu alaikum. Welcome to lecture number 45 of the course on statistics and probability. Yes, the last lecture of this particular course. Students, you will recall that in the last lecture I discussed with you the chi-square test of goodness of fit, and we applied this concept to the example in which we fitted the binomial distribution to real data. In today's lecture, I will be applying this concept to the case of the Poisson distribution. And as you now see on the slide, the platform manager of an airline's terminal ticket counter wants to determine whether customer arrivals can be modeled by using a Poisson distribution. The manager is especially interested in late-night traffic. Accordingly, data for the time period of interest have been collected as follows. Number of arrivals per minute are 0, 1, 2, 3, and so on, and the frequencies are 84, 114, 70, and so on. And the sum of the frequency column is 400. The question is the distribution Poisson? Students, let us try to understand this problem. देखिए, डेटा जो है उसमें आपने देखा कि जो फ्रीक्वेंसीज का कॉलम है उसका सम है 400 और हमारा जो वेरिएबल है दैट इज द नंबर ऑफ अराइवल्स पर मिनट. तो इसका मतलब ये हुआ कि 400 मिनट्स का डेटा लिया गया and they should have been selected at random if this distribution, if this whole method is to be properly applied. अब ये जो 400 मिनट्स हमने randomly select किए उनमें हमने देखा कि per minute how many people are arriving और वो डेटा आपके सामने है. As you once again see on the screen, corresponding to the number of arrivals per minute equal to 0, the frequency is 84. तो इसका मतलब क्या हुआ कि 84 minutes इस किस्म के थे when we did not have even one person arriving. Similarly, 114 minutes were such when only one person arrived at the counter, and 70 was such when there were two persons arriving in that 1 minute. Students, the question is this distribution Poisson? आपको याद है ना, जब मैंने आपके साथ Poisson process डिस्कस किया था तो उसको किस तरह से डिफाइन किया था? A process where events occur randomly either over a time scale or over a distance scale. यहाँ पे जाहिर है कि हम टाइम स्केल की बात कर रहे हैं and 1 minute is being regarded as 1 unit of time. तो हमें जाहिर है हम यही समझ रहे हैं कि customer arrival जो है that is a random process. So we would like to think that this data should be fitted by a Poisson distribution. If I do want to fit a Poisson distribution to this data, students, what will be the procedure? आपको याद है कि binomial के केस में हमने सबसे पहले x bar compute किया and then we equated x bar to np. N was already known and so P was found using this equation. अब इस particular situation में students, the one lone parameter of the Poisson distribution is mu, where mu is the mean itself of the Poisson distribution. अब वही पहले वाली बात कि mu तो available नहीं है, लिहाजा we will have to replace it by its estimate, and that of course is x bar. So, as you now see on the screen, in order to compute x bar, we construct the column of fx, which is the product, obviously, of the x column with the f column. Sigma fx is equal to 800, and dividing by 400, x bar comes out to be equal to 2. Now, the formula of the Poisson probabilities is e raised to minus mu, mu raised to x, over x factorial. But since we have to replace mu by x bar, our formula becomes e raised to minus 2, 2 raised to x over x factorial. Applying this formula, students, we obtain the Poisson probabilities, as you now see in the third column on the slide in front of you. आप जाहिर है कि x की values put करेंगे इस formula के अंदर 0, 1, 2, 3, 4 and so on, and you obtain probabilities as 0.1353, 0.2707 and so on, such that the sum of the probabilities is 1. Multiplying the probabilities by 400, the sample size, we obtain the expected frequencies, which are 54.12, 108.28 and so on. Students, now that we have computed the expected frequencies, of course, now is the time for us to apply the chi-square test of goodness of fit. कि हम ये भी तो देखें ना कि अब ये जो fit किया है हमने, क्या ये सही fit हो रहा है on the observed frequencies? So, as you once again see on the slide, given the column of the observed frequencies OI and the column of the expected frequencies EI, we will be constructing and the column of OI minus EI whole square divided by EI. Adding this last column, chi-square comes out to be 78.88. But students, please, before you go on with the thing, please note that we have combined the last four values, the last four categories that we have. ये हमने क्यों किया? देखिए, हम नीचे से ऊपर की तरफ combine करना शुरू करेंगे, हत्ता के हमारी expected frequency 5 या 5 से बड़ी हो जाए. If I add 0.08 to 0.36, the sum is still less than 5. When I add 1.36, the sum is not yet 5. And then when I add 4.80 to the sum of the first three, I obtain 6.60 as the expected frequency. Since I have combined the expected frequencies, I must also combine the observed ones, and thus I obtain 24 corresponding to 6.60. And students, these are the two numbers that will be used in order to find OI minus EI and the other quantities in that particular part of the table. ये सारी बात जो मैंने आपके साथ की, students, I hope you remember that even in the last lecture I mentioned to you that this is a very basic requirement of this particular test, the chi-square test of goodness of fit, that none of the expected frequencies should be less than 5. And therefore, if we do obtain some which are less than 5, then we will add in the manner that I just explained, so that the thing that we get ultimately is 5 or more. All right, let us have a look at the slide one more time. The sum of the last column is 78.88, and this particular chi-square statistic follows the chi-square distribution having k minus 1 minus r degrees of freedom, where k is the number of categories that we have after having combined any classes that we needed to combine. Therefore, if you count now, after having combined the last four, we have 7 classes and not 10. आप देख रहे हैं कि हमारे पास जो actual data है, that is from 0 to 9 or more, और उस हिसाब से 10 classes हैं, लेकिन जब हमने combine कर दिया, we are left with 7. Therefore, k is equal to 7. All right, k तो determine हो गया. And what is r? You will recall from the last lecture that r is the number of parameters that you estimate from the sample data. As I just said, there is only one parameter of the Poisson distribution, mu, and we are estimating it by x bar. Therefore, r is equal to 1. So, the degrees of freedom for this particular statistic are k minus 1 minus r, that is 7 minus 1 minus 1. That is 5 degrees of freedom. And students, आपको ये भी याद होगा कि मैंने आपको लास्ट टाइम बताया कि दिस इज अ राइट टेल टेस्ट. द इंटायर लेवल ऑफ सिग्निफिकेंस, द इंटायर एरिया हैज टू बी इन द राइट टेल. तो अगर इस पर्टिकुलर सिचुएशन में if we set alpha equal to 0.05, then we will look in the chi-square table under 0.05 against 5 degrees of freedom. And as you now see on the slide, the critical value is 11.07. Since our computed value 78.88 is much, much larger than 11.07, therefore, it is evident that in this particular problem, we reject the null hypothesis which said that the fit is good, and we conclude that it is not a good fit. In fact, students, ये 78.88 जो हमारा result आया है, it is so much larger than 11.07 that we are inclined to think that it might even be highly significant. आपको याद है ना कि अगर आपका लेवल ऑफ सिग्निफिकेंस 5% की बजाय सिर्फ 1% हो और उससे भी आगे निकल जाए आपकी कंप्यूटेड वैल्यू, then of course we say that it is not only just significant but highly significant. So I would like to encourage you to have a look at the chi-square table for 5 degrees of freedom under 1% alpha and then find out for yourself. All right, the next point I would like to convey to you is what is the rationale of this point that I said कि ये वाला जो टेस्ट है this will always be the right tail test. Students, आप chi-square के फॉर्मूले पे गौर कीजिए. OI minus EI whole square over EI and then you add these up. ये जो OI minus EI है, ये क्या चीज़ है? It is the difference or the distance between the observed and the expected frequency. हम उनका आपस में जो फासला है ना, उसी को तो जज कर रहे हैं. If those distances are small, then their squares will be small, and when you add all those quantities, whatever you do, after that when you add that thing, वो भी छोटा होगा ना. अगर वो distances ही बड़े हैं, तो जाहिर है कि उनके squares भी बड़े होंगे और वो सब कुछ करके ultimately जो कुछ मिलेगा, that will also be relatively big. In fact, don't you see students कि अगर आपकी expected frequencies आपकी observed frequencies के साथ exact tally कर जाएं, then OI minus EI will be equal to 0. और अगर वो सारे इस तरह से 0 हो जाएं, what will be chi-square equal to? Obviously 0. So यानी ये तो ideal situation है कि भाई आपकी जो expected frequencies हैं वो exact match कर रही हैं with your observed frequencies. इससे बेहतर fit कोई हो सकती है? Of course, we cannot expect such an ideal situation in the real life world where we have so much randomness. But I hope that you have got the essence of the whole discussion, that the smaller the value of chi-square, the more evidence there is that it is a good fit. वो तो सिर्फ अगर large होगा, यानी वो discrepancies large हैं और इस वजह से chi-square has come out to be large. If it is so large that it falls in the tail, the right tail of the distribution, इतना ज़्यादा वो large हो जाए और 0 से इतना दूर चला जाए, then we say that this is not a good fit and we should reject H0. All right, students, now let us start the discussion of the chi-square test of independence. और आप interested होंगे कि अभी आप देखेंगे कि इसमें जो formula है that is quite similar to the one that we just had, and actually this can also be regarded as a kind of chi-square test of goodness of fit. चलिए देखते हैं. Let me explain this concept with the help of an example. A random sample of 250 men and 250 women were polled as to their desire concerning the ownership of personal computers. The following data resulted. अब आप देख रहे हैं कि आपके पास एक bivariate table है जिसमें in the top row you have the men and the women, and in the first column you have the two situations. Either they want to own a PC or they don't want a PC. Now, the figures in the body of the table are 120, 130, 80 and 170. आप देख रहे हैं कि 250 मर्दों में से 120 चाहते हैं कि उनके पास पर्सनल कंप्यूटर हो, जबकि खवातीन जो 250 हमने चूज की उनमें से 80 are of this type. We would like to test the hypothesis that the desire to own a PC is independent of the sex of the person, and we would like to conduct this test at the 5% level of significance. This test involves exactly the same kind of a pattern as we have had before. The first step is the formulation of the null and the alternative hypotheses, and the null hypothesis students in any such situation will always be that the two variables of classification are independent, whereas the alternative hypothesis would always be that the two variables of classification are not independent. Students, ये जो मैंने आपको null or alternative hypothesis दिए, the underlying mathematics of this procedure is such that, as you know, we always begin by assuming that H0 is true. तो इसमें अगर हम H0 ये रखें that the two variables of classification are independent, तो फिर आगे हम सारे जो steps हैं इस hypothesis के under conduct करेंगे, और उसी सूरत में हमारी expected frequencies और हमारा chi-square उस तरीके से compute होगा जिस तरीके से compute किया जाना चाहिए इस किस्म के testing के अंदर. All right. After having set the hypotheses, of course, the second step is the level of significance, and we can, as usual, set it at 5%. The third step is the test statistic, and as you now see on the screen, the test statistic in this situation is chi-square is equal to sigma sigma Oij minus Eij whole square over Eij. And please note that the first summation is over I and the second is over J. Students, मैंने आपसे कहा था ना कि उसका जो पैटर्न है वो बहुत सिमिलर है to the one that we had before. जो फर्क है ना वो ये है कि हम कह रहे हैं कि सिग्मा सिग्मा Oij माइनस, लेकिन ये Oij में Oij मैं पंजाबी में नहीं कह रही हूँ. I am saying it in English. And why is it that we have a double summation, students? The reason is that, as you know, in this case, we have a bivariate table. So, I represents rows and J represents the columns. और वो सब कुछ करके हमने जो sum निकालना है ना, that is over all the values, and therefore, we have the double summation. All right, what is the next step? Of course, the fourth step is to compute our test statistic. तो इसके लिए students पहले हमें Eij, जो कि इस particular problem में there are 4, E11, E12, E21 and E22. These have to be computed. And as you now see on the slide, E11, that is the expected frequency of the first cell, the cell lying in the first row as well as the first column. Students, this expected frequency E11 is obtained by multiplying the marginal total directly to the right of this cell by the marginal total directly below this cell and dividing this product by the grand total 500. Hence, E11 is equal to 200 into 250 over 500, and that is equal to 100. Students, ये जो formula है ना, this is according to what you learned quite a few lectures ago, that if two events A and B are independent, then the probability of A and B is equal to the probability of A into the probability of B. उसी की एक मॉडिफाइड फॉर्म आपने अभी इस्तेमाल की, एंड दिस इज द वे यू विल कंप्यूट ऑल द एक्सपेक्टेड फ्रीक्वेंसीज. मैं फिर रिपीट करती हूं, जिस सेल की एक्सपेक्टेड फ्रीक्वेंसी चाहिए उसके सामने वाला टोटल उसके नीचे वाले टोटल से मल्टीप्लाई कर दीजिए एंड डिवाइड दिस प्रोडक्ट बाय द ग्रैंड टोटल of all the observations. Next, of course, we will construct the columns of OIJ minus EIJ and the square and so on. And hence, as you now see on the slide, constructing all those columns, chi-square comes out to be 13.33. Students, ये जो columns हमने बनाए हैं, ये अब आपकी अपनी मर्जी है कि आप किस ऑर्डर में OIJ की वैल्यूज इस कॉलम में लिखें. बट द ओनली थिंग दैट यू हैव टू कीप इन माइंड इज दैट whichever order you choose for the OIJ, the same order must be maintained for EIJ. Students, what is the fifth step of any hypothesis testing procedure? The critical region. Now, in this particular situation, it can be mathematically shown that this particular statistic, chi-square, follows the chi-square distribution having r minus 1 into c minus 1 degrees of freedom, where r is the number of rows and c is the number of columns. इस particular example में r is equal to 2 and c is also equal to 2. Therefore, we have 2 minus 1 into 2 minus 1 degrees of freedom, that is 1 degree of freedom. So, looking at the chi-square table, against 1 degree of freedom under 0.05, we obtain, as you now see on the slide, 3.84 as the critical value. The last step is the conclusion, and since our computed value 13.33 is larger than 3.84, therefore, we reject H naught. Students, हमारा null hypothesis क्या था? That the two variables of classification are independent. यानी the sex of the person and the desire to own a personal computer, these are independent. गोया उसकी जो sex है उससे इस बात का कोई ताल्लुक नहीं है कि उसको personal computer चाहिए कि नहीं. लेकिन we have rejected this hypothesis. That means that we are saying that the two variables of classification are associated. तो फिर naturally सवाल पैदा होता है कि फिर कौन सी gender है जिसमें it is a higher proportion of persons who would like to have a personal computer. अगर ताल्लुक है सेक्स का इस चीज के साथ तो फिर तो हमें इसको स्टडी करना चाहिए ना कि किस कैटेगरी में this thing is more prevalent. So, let us have a look at the data once again. As you now see on the slide, out of the 250 men, 120 are such who would like to have a PC, whereas out of the 250 women, only 80 are of this type. Now, since our chi-square has come out to be significant, therefore, we can say that this difference that we can see in the data, this indicates a significantly higher proportion of men wanting to have a personal computer as compared with women. Students, with reference to the chi-square, always keep in mind the very important point that for both the chi-square test of goodness of fit and the chi-square test of independence, the number of observations in our sample should be at least 50. Otherwise, this procedure of hypothesis testing will not be suitable. Students, ये जो example हमने किया, this was the simplest case when our bivariate table, which is technically called a contingency table, it was only a 2 by 2 table, सिर्फ 2 rows और 2 columns. But of course, we can apply this procedure when we have more than 2 rows or more than 2 columns. So, let us consider one more example. As you now see on the screen, A national survey was conducted in a country to obtain information regarding the smoking patterns of the adult males by marital status. A random sample of 1,772 citizens, 18 years old and over, yielded the following data. Now, students, you can see that we have 4 categories for marital status: single, married, widowed, and divorced. And we have 3 categories for smoking pattern: total abstinence, यानी बिल्कुल नहीं पीते, only at times, कभी कभार, and regular smoker. We would like to use this data to decide whether there is an association between marital status and smoking pattern. Students, all right, I would like to throw this as a challenge to you. आप ये test खुद conduct कीजिए. The steps are absolutely similar to the ones that we just did. So please conduct it yourself and find out whether there is an association between the marital status and the smoking pattern, or whether you do not find such an association and you accept the null hypothesis that the 2 variables of classification in this case are independent. Students, ये जो सारी discussion हमने अभी की, this is to determine whether or not there is an association between 2 qualitative variables, जैसे sex of the person and whether or not he or she wants to own a personal computer. Obviously, these are qualitative variables. अगर हमने quantitative variables के दरमियान आपस में relationship मालूम करनी हो, तो हम क्या करेंगे? You will recall lecture number 15, in which I discussed with you in detail the concepts of regression and correlation. Students, वहाँ जो हमने R की बात की थी और regression line fit की थी, that was in the area of descriptive statistics. But then we also have methods by which we can do inferential statistics regarding regression and correlation. We can test hypotheses about rho, the population correlation coefficient, and beta, the population regression coefficient. जो हमारे पास होते हैं R और B, they are of course the sample values. But we would not have a chance to discuss those in detail in this particular course, क्योंकि students, अगर हम इस तरह से देखें तो इस तरह से तो अभी और भी बहुत सी चीज़ें हैं which could be discussed, but the basic purpose of the course is to give you an insight into the fundamentals of the subject, and I think that what we have done up till now would suffice for that, inshallah. All right, this brings us to the end of the series of topics that I wanted to convey to you in some detail in this course. For the remaining part of today's lecture, students, I will be conveying to you a few very, very interesting points, the very first of which is the degrees of freedom. आपको याद है ना कि T distribution, chi-square distribution और F distribution की discussion के वक्त हमने degrees of freedom की बात की थी. And I said to you that the parameters that exist in the mathematical equations of those distributions, they are called degrees of freedom. मगर सवाल ये पैदा होता है कि why on earth are they called degrees of freedom? What do we mean by that? Let me try to explain this to you with the help of an illustration. ये पेंसिल जो है, अगर आप एक प्लेन कंसिडर करें और उसके अंदर इसको एक लाइन सेगमेंट तस्वर करें और उसके बाद ये देखें कि ये वाला जो इसका कोना है, अगर मैंने इसको यहाँ पे फिक्स कर दिया, this thing is still free to move in this plane. It can be rotated and एक तरफ से restriction है, but otherwise it can move. So we have 1 degree of freedom. Students, अगर मैं दोनों पॉइंट्स को फिक्स कर दूं, now I do not have any degree of freedom for the movement of this pencil or the line segment. But if we step into the 3-dimensional world, the one that you and I live in, फिर आप नोट करेंगे कि ये जो प्लेन, ये पूरा जो प्लेन है ना, जिसके अंदर ये फिक्स्ड है, this plane itself is able to move in this three-dimensional world. And in the 3 dimensions, I do have 1 degree of freedom. So this is the kind of concept that is involved in this discussion. Now, coming to our statistical work, आपको याद है कि जब हमने टेस्टिंग की थी H naught mu is equal to something against H alternative, that mu is not equal to that quantity, and if we were using the t-test, we said that the t-statistic x bar minus mu naught over s over square root of n follows the t-distribution having n minus 1 degrees of freedom. तो ये n minus 1 क्यों है? Let me explain this with the help of an example, which you now see on the slide. Suppose that we have a sample of size n equal to 6, and suppose that the sum of the sample values is 20. That is, we have the following situation. एक टेबल आपके सामने है जिसमें पहला कॉलम जो है, that is giving you the serial number of the 6 values that you have, and as I just said, the sum of the values is 20. Now students, note कीजिए कि इस situation में पहली जो 5 values हैं, you may choose them freely, but once you have chosen the first 5, you are not free to choose the 6th one. इसलिए, because the sum is 20. अगर पहली 5 values आप freely choose कर लें और उनको choose करने के बाद आपका उन पहली 5 values का जो sum है ना, that comes out to be 17. तो फिर ला मुहाला 6th value has to be equal to 3. Hence, we do not have 6 degrees of freedom to choose values, but we do have 6 minus 1, that is 5 degrees of freedom. तो देखा आपने students, it's quite an interesting concept. इसी बात को एक और तरह से समझने की कोशिश करते हैं. All right, I have 6 observations. I find their sum, and then I throw away one of those 6. Students, I can regenerate that one that I have thrown away because I already know the sum and I know I have the other 5 values. तो degrees of freedom जो है ना, they are 6 minus 1. वो एक जो मैं regenerate कर सकती हूँ, that is the one for which I do not have the degree of freedom that can also be chosen freely. वो तो उन बाकी 5 values से ही regenerate हो जाएगी. So this is the kind of concept why we say that we are dealing with degrees of freedom. Coming back to the t distribution, the chi-square distribution, the f distribution, students, generally we can define degrees of freedom in this manner, that the degrees of freedom are the total number of observations in our sample minus the number of parameters that you estimate from the sample data. ये जो t distribution की बात है, यही कर लेते हैं सबसे पहले. As you now see on the slide, in testing, H naught, mu is equal to mu naught against H alternative, that mu is not equal to mu naught. Our statistic, x bar minus mu naught over s over square root of n, follows the t distribution having n minus 1 degrees of freedom. Here, the point to be noted is that s is the estimate of sigma, the population standard deviation. गोया हम एक पैरामीटर जो है population का, that is the standard deviation, उसको हम estimate कर रहे हैं by the sample standard deviation small s. चूंकि हम एक पैरामीटर, चाहे आप उसको standard deviation कह लीजिए या population variance कह लीजिए, चूंकि ये एक पैरामीटर estimate किया जा रहा है from the sample data, therefore the degrees of freedom are n minus 1. इसी तरह f statistic की बात कर लेते हैं. You will recall that when we were trying to test H naught, sigma 1 square is equal to sigma 2 square. Our test statistic was f is equal to S1 square over S2 square. और हमने कहा था कि ये स्टेटिस्टिक N1 minus 1, N2 minus 1 degrees of freedom वाली F distribution को follow करता है. Why do we have N1 minus 1? Because S1 square that we have in the numerator is an estimator of sigma 1 square. तो हमने गोया एक parameter estimate किया and hence N1 minus 1 degrees of freedom for the numerator. And a similar situation holds for the denominator. और जो अभी हमने थोड़ी देर पहले chi-square test of independence conduct किया, उसमें तो बहुत ही interesting situation है. I said to you that we have R minus 1 into C minus 1 degrees of freedom. तो ये किस तरह से हो गया? वो जो example था कि जिसमें either man or woman and either you want a PC or you don't want a PC, तो उसमें 2 rows and 2 columns, and therefore we have 2 minus 1 into 2 minus 1, that is 1 into 1, and that is 1 degree of freedom. ये कैसे हुआ? Let us look at that table once again. Now I am presenting to you the same table in such a way that I do have information regarding the marginal totals and the grand total, but I have removed the 4 data values that I had in the body of the table. For example, suppose that the value of a cell is 100. Then automatically the value in the second cell of the top row will also be 100 because the sum of the row is 200. And the value in the second cell of the first column will be 150 because the sum of that column is 250. And then, of course, we can also find the value in the last cell, that is the cell in the second row and the second column. So, lubbe lubab ye students that you can choose only one value freely. बाकी तीनों की तीनों जो है ना, वो तो उन मार्जिनल टोटल्स की वजह से डिटरमिन हो जाएंगी. आप फ्रीली चूज नहीं कर सकते. The only one that you can choose freely, that may be in the first cell or in the second or third or fourth, उससे फर्क नहीं पड़ता. The point to note is that you have only 1 degree of freedom, and 1 can be written as 1 into 1, and that can be written as 2 minus 1 into 2 minus 1. In other words, R minus 1 into C minus 1. Of course, if you have a 2 by 3 table or a 3 by 4 table, तो यही बात जो मैंने present की, it will be in that context. और मैं आपको encourage करूंगी कि आप एक 2 by 3 table बनाएं और marginal total लिख लें और उसके बाद खुद इस पे work करें कि आया ये जो formula R minus 1 into C minus 1 वाला है, जो कि उस केस में 2 minus 1 into 3 minus 1 यानी 1 into 2 यानी 2 degrees of freedom के मुतरादिफ होगा. क्या वाकई उस टेबल में which has 2 rows and 3 columns, do you really have only 2 degrees of freedom? इस पे आप खुद वर्क कीजिए. Alright, students, the next concept is that of the P value. आपने देखा कि हमने बहुत सारे hypothesis test किए. We discussed various procedures, but in every situation, what we were doing was that we determined the critical region and we decided whether our computed value falls in the acceptance region or in the critical region. But students, we can also draw a conclusion regarding our hypothesis by means of what is called the p-value. As you now see on the slide, the probability of observing a sample value as extreme as or more extreme than the value that has been observed, given that the null hypothesis is true, this probability is called the p-value. Students, I would like to explain this to you with the help of the example in which we considered the hourly wages of computer analysts and registered nurses. As you will recall, the statement of the example was, a survey conducted by a market research organization 5 years ago showed that the estimated hourly wage for temporary computer analysts was essentially the same as the hourly wage for registered nurses. This year, a random sample of 32 temporary computer analysts from across the country is taken. The analysts are contacted by telephone and asked what rates they are currently able to obtain in the marketplace. A similar random sample of 34 registered nurses is taken, and the resulting wage figures are listed in the following table. As you can see, the wages are 24.10, 23.75, and so on for the computer analysts, and similar figures for registered nurses. We would like to conduct a hypothesis test at the 2% level of significance to determine whether the hourly wages of the computer analysts are still the same as those of the registered nurses. Students, you will recall that our null hypothesis was mu1 minus mu2 is equal to 0 against the alternative that mu1 minus mu2 is not equal to 0. We carried out various steps, and the computed value of our test statistic came out to be 3.43, which was greater than the tabulated value, the critical value 2.33. Hence, we rejected H0. The figure that you now see on the screen illustrates this point. आप देख रहे हैं कि हमारी value 3.43 जो है, that is lying in the right tail of the sampling distribution, and it is to the right of 2.33, and therefore we reject the null hypothesis. Students, ये जो result हमने obtain किया, we could also have got the same result by the p-value method. अब p-value क्या चीज़ है? सबसे पहला step जो है वो ये है कि आप compute कीजिए how much area lies to the right of our computed value. So, as you now see on the slide, the value 3.43 in the right tail of the standard normal distribution is in front of you, and as you can see, the area beyond this point is 0.0004. Of course, we get this area by looking up the area table of the standard normal distribution. Now, since this is a two-tailed test, therefore, we are interested not only in this area which is on the right tail, but also the area which is to the left of minus 3.43. And obviously, that is also equal to 0.0004. Students, in this situation, the p-value is given by 0.0004 plus 0.0004, and that is equal to 0.0008. यानी हमने इस बात की probability compute की है students कि हमारी जो value actually आ गई उतनी बड़ी value या उससे भी ज़्यादा बड़ी value, और चूंकि ये टू टेल टेस्ट है तो साथ ही हम कहेंगे कि उसका जो नेगेटिव काउंटर पार्ट है उतनी छोटी वैल्यू या उससे भी ज़्यादा छोटी वैल्यू होने की प्रोबेबिलिटी कितनी, कि इस बात की प्रोबेबिलिटी कितनी थी कि हमारी वैल्यू इतनी एक्सट्रीम पे होती. एंड वी हैव फाउंड दैट इट इज ओनली 0.0008. Now, since this is extremely small and much smaller than the level of significance, that is 2% in this problem, therefore, we reject H0. Students, we always begin by assuming that H0 is true. Point ये है कि अगर H0 सच है, तो फिर इतनी एक्सट्रीम वैल्यू आने की प्रोबेबिलिटी क्या है? 0.0008. It is highly improbable. So if we have such a low probability for getting this value that we have actually got, then we say that there is something wrong and we cannot accept the null hypothesis in this situation. So therefore, we will reject it. I would like to encourage you to work on this problem on your own. आप बहुत से examples लीजिए, उनकी p values compute कीजिए और याद रखिए कि अगर one tail test है तो फिर आप दोनों tails के areas को add नहीं करेंगे. You will simply take the area in that one tail. हमेशा आप compute करेंगे the area beyond that value which you have actually got as your computed value of your test statistic. And once you have computed it, उसके बाद आपने सिर्फ ये देखना है कि is that large or is it small. As you can now see on the slide, the p-value is a property of your data and it indicates how improbable your obtained result really is. So if it is a very, very small figure, then we say that this result is very improbable under the null hypothesis and therefore we reject H0. A very simple way of understanding what interpretation to make is that if your p-value is less than the level of significance, then you will reject H0, and if it is greater, then you would accept H0. But I would like to encourage you to work on this problem on your own and to study quite a few textbooks and other books in this regard. What I would like to now discuss with you students is the relationship between interval estimation and hypothesis testing. Students, शायद आपके अपने ज़हन में ये बात आई हो that there seems to be a relationship between interval estimation and hypothesis testing. After all, do you not remember that when we derived the confidence interval for mu, हमने दरमियान में एरिया रखा था 1 minus alpha, इस साइड पे alpha by 2 और दूसरी साइड पे भी alpha by 2. And when we did hypothesis testing, in case of a two-tailed test, if our level of significance is alpha, then we have alpha by 2 area on this side and alpha by 2 on the other side. There definitely does seem to be some kind of a relationship between the two. So let me throw a proposition to you. As you now see on the slide, let L, U be the 95% confidence interval for the parameter theta, where L stands for the lower limit and U for the upper limit of the interval. Then we will accept the null hypothesis, H0 theta is equal to theta naught against H1 theta is unequal to theta naught at 5% level of significance if theta naught falls inside the confidence interval, but if theta naught falls outside the interval LU, then we will reject H0. In the language of hypothesis testing, the 95% confidence interval is known as the acceptance region, and the region outside the confidence interval is called the rejection region. Also, in this way, we can say that the endpoints of the confidence interval represent the critical values. Students, ये एक proposition मैंने आपके सामने present की है. I would like you to work on this on your own. आप एक sampling distribution लीजिए, उसके ऊपर interval derive कीजिए और hypothesis testing के हवाले से उसी के ऊपर critical values determine कीजिए और खुद कोशिश कीजिए कि आप देख सकें कि what kind of a relationship exists between interval estimation and hypothesis testing. You might arrive at the conclusion that what was just presented is correct, or you might arrive at something slightly different. So that is a challenge for you. Students, we are drawing close to the end of today's lecture and to the end of this course. But before I close, I would like to convey to you that statistics is a vast discipline. In this course, I have presented to you some of the very basic and fundamental concepts. But of course, there are numerous other concepts that could be discussed. For example, with reference to experimental design, we could talk about the Latin square design, factorial designs, and so many other very interesting and important designs. With reference to statistical inference, students, we could have talked about non-parametric statistics, non-parametric inference, and in a similar way, there are so many other topics that we could talk about. This particular course should be regarded as the beginning of a long journey in the science of statistics. And if you are interested, you would definitely want to pursue studies in this area at some stage or the other. Another very interesting and important point, students, that I would like to convey to you is that I have presented so many different problems and so many different techniques, and most of the time I have been presenting to you the solutions of the problems step by step in a lot of detail. The purpose was to give you an idea of the fundamental concept involved in that particular technique. But having said this, students, I would now like to convey to you that there are numerous computer packages that you can use and you can arrive at the solution within seconds. आप तो computer science के students हैं, आपसे ज़्यादा बेहतर ये बात कौन जान सकता है? And the packages are numerous, as I said: SPSS, SAS, Stata, S+, Minitab, and so on and so forth. So I would like to encourage you to attempt quite a few problems on these packages. आप मुझसे ज़्यादा बेहतर जानते हैं that you will simply be clicking a button and you will be arriving at all your regression coefficients and all kinds of things that you would like to do. And speaking of latest trends, students, I would now like to give to you one of the latest definitions of statistics. Statistics is a science of decision making for governing the state affairs. It collects, analyzes, manages, monitors, interprets, evaluates, and validates information. Statistics is information science, and information science is statistics. It is an applicable science as its tools are applied to all sciences, including humanities and social sciences. And students, at this point, I would like to repeat what I said in the very first lecture of this course. It has been said that statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. Yes, this is the importance of statistics. Students, education is a wholesome process. The essence of effective teaching is effective and inspiring communication on the part of the teacher and concentrated attention and effort on the part of the student. As far as the teacher is concerned, शायर के अल्फाज में टीचिंग इस तरह की होनी चाहिए कि कहा जाए कि देखना तकरीर की लज्जत कि जो उसने कहा, देखना तकरीर की लज्जत कि जो उसने कहा, मैंने यूं जाना कि गोया ये भी मेरे दिल में है. And as far as students' responsibility is concerned, as I said, it is concentrated attention and a lot of effort. जैसा कि कायदे आज़म ने कहा, काम, काम और सिर्फ काम. Students, if this course has been able to inculcate in you the fundamentals of statistical and probabilistic thinking, then it has served its purpose. I wish you the very best in your pursuit of knowledge. May Allah bless you with the wealth of knowledge and with the capability to utilize this knowledge for the betterment of humanity. सालिहा नग़मी को इजाज़त दीजिए. अल्लाह हाफ़िज़.